Mm-hmm. Mm-hmm. Yeah, everything in this booklet will be expected. Okay, so far we expected how scale factors affect dimensions, like just the one-dimensional, so length, width. Dimensions, if it's just mentioned like that, it's length, width, height, radius, diameter, all the linear components that make up a shape, okay? That's what we were doing so far. But how does enlarging or reducing an object affect the area, okay? How does enlarging or reducing affect the area, surface area, or volume? Okay. Remember when I gave you like 1 yard has 3 feet, let's say. Can we say that 1 squared yard has 3 squared feet? Can we say that? 1 yard has 3 feet? We can't say that. Like if some of you are perplexed a little bit. I know it's Monday. Okay. We know this one, right? Can you say 1 squared yard has 3 square feet? Is that correct to assume? That's wrong. Okay, this is wrong. So that's kind of the same idea. What did we do in order to get our squared units, what would we do to this expression here? We would square everything. So it's 1 squared yard has 9 square feet, correct? So that's kind of what this is going to cover as well. So if I already kind of hinted then to that. So let's explore. Consider the following rectangular prisms. Assume that the original has been enlarged by a scale factor of 2. Okay, so we used a scale factor of 2 to get from here to there. Okay. And remember, if you go from the original to the new, right, we went times 2. Right? K is equal to 2, so we basically multiply everything on this side by 2. Okay. So if this is 5, okay, then this would be 2 times 5, which will be 10 centimeters. If the width is 2, then this is 2 times 2, this is 4 centimeters. If you're looking at the height, guess what? 3 times 2, it's 6 centimeters. Okay, and every time I've applied the scale factor of 2 every single time. So A, determine the dimensions of the new prism. I've already done that. They're right here. Okay. So that's 10, 4, 6. Determine the surface area of each prism. So let's compare that. So if I go surface area of original, I go 2 times 5 times 2. Right, that's this here. Plus 2 times 5 times 3. Plus 2 times 3. And these dots are multiplication, right? That would be, this is 10, so 2 times 10 is 20, plus 3 times 5 is 15, times 2 is 30. Times 3 is 6, times 2 is 12. Okay, so our surface area is 62 centimeters squared. Okay, what about the surface area of the new shape, this one right here? I will do this a little differently. It's 2 times, right? Watch what I'm going to do here. 2 times 5 times, let me just do this here. Can you erase this 2 for now? We'll just call this K. K5, I'll just go K5 times K2. And before you're wondering, what in the world are you doing there? Remember, this was k times 5. When I went 2 times 5, I went scale factor times 5. This is k times 2, and this is k times 3. Everything has been affected by the scale factor to get to the new one. So plus 2 times, this would be k5 times k3 plus 2 times k2 times k3. All right, so how does this reduce? Let's watch this. 5 times 2 is 10, right? K times k is k squared. So you basically have k squared times 10 plus 2 times. And if you're scratching your head a little bit for now, just copy this and then later I'll highlight it. What is it that, why are we doing this? Okay. 5 times 3 is 15, and k times k is just k squared. So it's k squared times 15 plus 2 times. 2 times 3 is 6. K times k is k squared. So it's k squared times 6. And here's where I want to land right now. I want you to notice there's a k squared there, there's a k squared, and there's a k squared. Do you remember factoring in intro? I can take out the k squared from every single one of these expressions, right? I can take it out. So watch what I'm going to do. I'll go k squared, square bracket, and I'm left with 2 times 10 plus 2 times 15 plus 2 times 6. Then I'm left with k squared, and I'll just show you 2 times 10 is 20, this is 30, and that is 12. If you did the math, you would end up with 62 centimeters squared. Where else do we have the 62? Do you notice that? And the 62 is there. So the surface area of the new shape, this one, if we just look at their surface areas, right, you would just multiply the surface area of the original by whatever k is squared. Okay? So that's our finding here. Okay? I'm going to cut this here. So this is our finding. Oh, maybe I'll do one more here. K squared is basically surface area of original. And this is what I want you to really take home after doing this one. Okay? So it follows that k squared is going to be the surface area of the new shape divided by surface area of original. What do you notice about this formula here? Are there some similarities to the previous one when we just had k? New is always on top, original is always at the bottom, right? Still stays the same. So that doesn't change. And from this, if you wanted to find the scale factor, watch this, make sure you copy this right. You would simply take the square root of that expression. So I would say I would box them in separately. Like that. And these are the most commonly used. However, if it's diagram and actual, I will just rewrite this with diagram and actual so that if you come across a blueprint or a model or anything like that, you have those terminologies there. So k squared is equal to surface area, or area for that matter, of diagram over surface area of actual. And let's do this, the root as well. You know what? I'm gonna, with a red pen, some students miss this. It's assumed that you first want to divide and then root. So technically you need a, come on. You can do it, there we go. So inside the root, it's very important that you make sure you, the calculator usually starts with a bracket anyways. So if I were to make my study sheet, I might not need the diagram actual. I'm just going to be happy with this. But if you are not sure, then I would just have all four of these. It doesn't take up that much space, and then you're safe. Okay. All right. Similarly with the volume. Guess how the volume is going to work? If it's k squared for areas, the volume will be k cubed. That's all. So determine the volume of each prism. So we're going to go volume of the original. Do you remember volume of a box? It's just 5 times 2 times 3. It's length. Length times width times height. Sorry, you can't see that. Length times width times height is the volume. So let's figure out what that is. 5 times 2 is 10, times 3 is 30. Cubic centimeters. Volume of the new, every single dimension, right, has been affected by 2, which we call k. K? I'm just trying something here. K times 5, right? How about we put them in little brackets? Times k times 2 times k times 3. Too many brackets, right? That's probably like a killer emoji if you type that into your phone right now. Okay. I hope it's appropriate though. Nowadays you never know. But k times k times k, that gives you, because these can all be multiplied. That'll give you k cubed. And let's put this separately, the numbers. 5 times 2 is 10, times 3 is 30. What do you know? I'm going to use pink or something. Okay. The 30 shows up here again. And so technically what we could have said is that the volume of the new is simply the scale factor cubed times the volume of the original. That's technically what we could have concluded with. Yeah. And I used up too much space for the other one, so let's try to be a little more conservative. So it turns out that k cubed is volume of new over volume of original. And let's do what do you think you're going to have to do to get k on its own if you know both volumes? Cube root. So it's k is equal to cube root of v new over v original. Okay? These are very much related. And some students might not need the cube root there because they just know it's k cubed, so obviously you have to do the cube root to get the scale factor. Same way, volume of diagram over volume of actual. And I know this is annoying, I get it, having the terminology switched on you, but Unfortunately, the problems are, they do vary. So you can't get away from it. So let's make sure with the red pen, we make sure. And you know what? This is going to be a unit that we've done way at the beginning, so you might forget how to do cube root. But to get cube root, you press math, you press the math button and you find it, okay? So maybe you might have to make a little note to yourself, because remember, there's no cube root on this thing. So you have to press math, and then it's the fourth option right there. So I would make a note on my study sheet how to get that cube root button, right? Or that feature. All right, I'm going to tell you this right off the bat. Do you need all of this stuff? No. This is me just trying to prove why this is true, okay? So don't worry about it too much. Just make sure you have these formulas on your study sheet. And this would be 2-dimensional and 3-dimensional, okay? Maybe I'll do this. I'm trying to help you out here. You do whatever you need to do. But if you ever see centimeters squared or meters squared or square feet, anything squared, you know that you have to use, I'm just gonna stick with this. You're gonna have to use this setup, right? And then possibly take the square root if you notice the units are squared. If you notice the units are cubed, I'm gonna get rid of diagram for now. Then you're going to have to use this setup right here if you notice your units are cubed. So cubic inches, cubic feet, cubic centimeters, anything like that, you should immediately recognize you're in this territory, okay? And that you will have to take the root if you're trying to find a scale factor. There's no way around it, okay? So let's use these formulas and apply them to different scenarios. So I'll do a couple, and that'll be it for today. I'm going to ask you to try this already at home, okay, after today. And if you have questions, you bring them tomorrow. No problem. Here we go. Consider two similar cylinders shown below. By what factor has the height and the radius been affected? You know what? I will use this tomorrow. So I'm going to skip a few pages. It's just to prove the point even further, okay? So let's just go to 37. I'm actually not sure if I'm going to use that, to be honest. That is only if time allows that I use that. 37, okay? I know you're tired. We can do this, and then you can eat your lunch. An ice cream shop is making smaller cones, right, for small children. Use the diagram to answer the following. Determine the scale factor, right, created to make the smaller cone. In this case, if you look at the dimensions, are there any squared units or anything like that? No, it's just inches, right? Both of them are inches. I don't even need to convert. So I'll just go like this. It's the diagram, or new, right? Replica would be new. Let's put new on top of replica. 1.77 inches over 2.5 inches. Cancel them out. And this one isn't pretty, so I'm just going to leave it. I'm just going to say, just go 1.77 divided by 2.5. And in this case, it rounds to 3 decimals. Let's use them all. Okay. Boom, that's your scale factor right there. I think that one is no news there. Now, determine the amount of waffle dough required to make the original cone. It's asking you for surface area. You should immediately think 2-dimensional. And you should think k squared. Okay. All right, so we're going to say k squared is surface area of the new divided by surface area of original. What do I know already? Do I know k? Yes, I do. So I'm going to use that. I'm going to actually make an arrow and say I know k. I'm not going to find it. So I'm going to go 0.708 over 1 I know some of you might think that's unnecessary. You go ahead and just remove it, right? I'm going to square it because that's what that is saying. Which surface area do I know? This one I kind of give you. You don't know the surface area of the original, but you do know the surface area of the new one, right? So where does that number go? On top. And I'm in squared inches, right? It's another giveaway that you should have squared your scale factor. And I'm just going to call this, I'm going to keep it surface area original. You can later on just turn it into an X if you want. And watch what I do. I square this, 0.708 x2, and I don't round it. So I'll go 0.501264 over 1, and that's 1015 squared inches, and this is surface area of original. What do you do now? Just like before, cross multiply and divide, that's right. Multiply this way, divide up. So surface area is 10.15 times 1. You don't have to type that into your calculator. And watch what I do. You can just go dot, dot, dot. You're telling me you're using all decimals. So it's basically 1015 divided by, I'm just going to go copy paste. And that's 20.25, right? Squared inches. And there you have it. The bell is going to go any moment now. So what I'm going to ask you to do, I'm not going to give you a whole lot. I'm just going to go 37 to 39 and stop there. And I know the pages seem overwhelming, but you can tell that I always leave you tons of space to try this. In fact, there's so much space that you can do your work, and if you get it wrong, you can just cross it out and just copy what I'm doing the next day, right, when I go over it. So remember the attempting part. I know this is going to be challenging, perhaps, and that's okay, but I need your brains to interact with this a little bit before I take it on tomorrow, okay? Thank you, guys.